Hello there and welcome back to the series about LangChain applications with Redis. In this video, I'm going to show you how to implement the concept of a chat message history using the constructs available from LangChain and using Redis as the storage from the chat message store. Now, remember that this is part of a series and all the code that we're showing here is part of the GitHub repository that you can find here on the link for it in the description of this video, right? Also, make sure to create the database that we're using right throughout the series using the steps shown on the first video of the series where I show you how to create a Redis database on Redis Cloud for free. So make sure that all those two steps are done before you continue to follow up and tag along with this video, right? So as I mentioned before, this video is going to be about implementing the chat message history with Redis and LangChain. And for our code, you are going to use this Jupyter notebook here called chat history, right? So just like I did with the previous videos, I went ahead and took care of the installation of the requirements and dependencies, LangChain, Redis, OpenAI. We're going to use LLMs for this one as well. And then I also already imported all the libraries that we're going to use in our code. So this is done. And we're going to actually now set up the Redis connection. So we're going to have this connection with Redis, and we're going to reuse this throughout the code so we can store and read all the information from Redis. What this code is doing is basically using the packet Redis, and then from the URL, we're providing the URL here, we're creating a Redis client, and then we're performing a ping request to that from that client to Redis to make sure that we have connectivity established. We're not going to use this local connection to Redis, but instead we're going to use the Redis database running on Redis Cloud. So I'm going to jump back to my Redis Cloud account, and then I am going to select the database, and then we're going to scroll down here and click on this connect button. Once you're done here, let me put myself on the side here so you can see everything that I'm doing here. You are going to select this option, Redis CLI, right? But with the purpose, not necessarily that use with a Redis CLI. If you wanted, you can do it. But what we're actually after here is the Redis URL, which is this string over here. Before you copy, make sure to click on this I icon here so you can review the password for your Redis database. And then you copy the Redis URL, and then you go back to your code and replace the value of this variable here called Redis URL, right? So let's execute this code. And then as you can see here with this value true, it means that our ping request was able to reach the Redis database on Redis Cloud. So we're good to go. And then the next step, we're going to set up our OpenAI API key. This is going to be used for us to instantiate an LLM that we're going to use for the purpose of establishing and creating a chat history with a conversation that we're going to implement with the LLM. And then we're going to use OpenAI for this. If you have never created an OpenAI API key before, I'm going to put here on the description of this video the link where you can learn how to create your own OpenAI API key, right? So once you have done this, make this OpenAI API key available as an environment variable under this name over here, right? So you can retrieve it from the environment variable, and then you can follow up with the remaining of the code, right? So we're going to explore two examples of a chat message history here. Right? The first one, it might seem not so obvious at first, but this is what we call interacting directly with a message history store, or in other words, populating manually a message history store for the purpose of maybe enriching any conversation that you might have with any given person for a chatbot, for example, right? So what you can do, you can create this construct here called Redis chat message history, and then you are going to create a unique session. This is very important because whatever value you set here as a string, this is what is going to be used uniquely to separate the session from other users. So it has to be a different value for each user, right? I'm counting with you that you know how to create unique values here for your sessions, right? And then you're going to provide the Redis URL that we created before, right? So once you have a history, you can add a user message to it, or you can add an AI message arguably something that represents a machine or an LLM, right? And then you can also peruse and browse all the messages that are available on this history, right? So in order to demonstrate this, I'm going to show real quick here that on our Redis Insight, there are no keys available. Everything is empty, right? So what we're going to do, I'm going to execute this code. And as you can see here, we're basically iterating over all the messages that we've stored on the history. So the first one, hello AI assistant, that's the human talking. And hello, how can I assist you today? That's the AI talking, right? So if you go back to Redis Insight and update the keys, you are going to see that now we're actually created a set of keys. Mind the prefix that we've using for those keys, Bob123. So this is no coincidence. This is basically because we provided the session ID of Bob, representing a person named Bob here. And then all the conversations that were given for the human, for example, the data is hello AI system, and that's the response from the AI. Everything was stored on the same prefixes of a key representing the session of Bob, right? So this is to prove to you that you can programmatically interact with your own chat history. Like I mentioned before, the use cases are limitless for what you are trying to accomplish here. Perhaps for each session that you already going to create for a user, you might have like some specific previous questions and answers that typically all the users make in a formula of an FAQ, if you will, right? So that's one of the use cases that you can use this construct here, which handling the chat message history directly from the LangChain API, right? The second use case, which is going to be a little bit more common, is the usage of a chat message history with a LLM, right? With a large language model. So this is where you are going to create a chain or a conversation chain with the LLM. And then within this conversation chain, you are going to associate a chat message history, right? It can be, there are multiple implementations of a chat message history in the LangChain framework, right? So one of them is when you can create this with Redis, right? That's what we're going to do here today. So we're created like this generic prompt, which is the system. You are a helpful AI assistant, hopefully, right? And the human is going to kind of carry a input, which is going to act as the prompt for the human, right? So here we're instantiating our LLM with the chat OpenAI, right? And then we're creating a chain out of the prompt previously created and the LLM, right? Hence the usage of the pipe here. We're chaining and piping everything, right? So the trick here is that we're creating a chain with a history, right? So actually we're instantiating a runnable with message history. This is another construct for LangChain. And then we're providing the chain that were previously created, this one over here. And then we're providing a way, a callback function, if you will, to programmatically create one instance of a Redis chat message history per interaction of the user. Because the same, let's think about this, the same chain can be used with multiple users, right? Connecting to a chat and talking to the LLM with it. So for each one of them, they may require a specific session. So that's why we've created this callback function here, get Redis history, that given a session ID is going to retrieve us with a base chat message history, right? Which this is an abstract class. So the actual concrete implementation that we're using in this case is a Redis chat message history, the same one that we have used before. So this is to prove to you that you can use a Redis chat message history individually, right? For a specific use case, for a specific session, for a specific user, or you can use this on demand. So each time a new user connects to the chatbot and the chain, a new Redis chat message history is going to be created for that individual, right? So that's why we're creating it as a callback. And then we are basically separating the input message keys given a unique name called input, and the history is we're basically calling history because it makes sense, right? Now, here's where the fun part starts, right? So the example that we're going to do today, we're going to use this chat with history here that we've created before, and then we're going to perform the following invocation, right? So the input's going to be, hi, my name is Alice, right? And then we're going to programmatically set that this session ID, that's where we're going to use this callback function here to create a session ID dynamically for Alice, right? And we're going to use the session ID Alice123, right? So this is going to be the invocation, and we're going to retrieve a response from the LLM, right, as always. And we're going to print that response, right? And then the second interaction is going to be using the same chain. We're going to ask the following question: what is my name, right? And then obviously that's the whole reason why we are using a chat history here. That's the usage, the use case of this building block for LangChain. If the chat history is being applied in a conversation, so it is up to the LLM to leverage this chat message history and remember that the person that I'm talking to, given the session ID, is Alice, right? So the assumption here is that when we retrieve this response, the AI response 2 is going to be, hey, your name is Alice. Don't you remember this? And then we are going to actually question, right, with a negative if this whole chat history implementation is effectively working, because we're going to ask again to the chain with history, what is my name? But this time, we're going to provide a different session ID called Jane123. So what needs to happen is that the LLM is not going to have the resources to answer that question, and then hopefully is going to respond, you know what? I don't know who I'm talking to. Unless the LLM hallucinates and try to kind of guess who the person is. But I'm pretty sure that the LLM is not going to do this. I'm hopeful that, right? So let's execute this code and see how that goes, right? So let's execute this code over here and see the responses. So the response number 1 is the result of, hi, my name is Alice, right? So the response was, hello, Alice, how can I assist you today, right? So, and that interaction, for the purpose of how the interaction with the LLM occurs, there was a finish of the transaction there. So for the LLM perspective, because it's a stateless machine, most of the time, it's not a stateless machine. It's actually most of the time is stateful for the backend's perspective, but the interaction with the client from the LLM, that's the stateless. So it's not supposed to remember anything, right? So that's the usage of a chat message history. So the second interaction, as you can see here, the response was, your name is Alice, right? And because we did the second iteration, which is, what is my name, right? Providing with the same session ID, Alice123, right? So that's why the AI, or should I say LLM, right, responded, hey, your name is Alice. So it is the proof that along with the second interaction with the LLM, which is stateless, the chat message history was applied as part of the context in the prompt, right? So this is very important about how you are going to leverage all those building blocks with LangChain, right? And then the result of this third interaction, which was the question, what is my name again? But this time using a different session ID, Jane123, right? So the response was, I'm sorry, but I don't have access to your personal information. Hopefully, right? If you would like me to remember your name for the future interactions, feel free to tell me, right? Which is, here is the LLM assuming that a chat message history might be in place, right? So this is I don't know if that was the case, right? But because the LLM sometimes might have access or not of the chat message history. But all of this is actually handled during invocation time by LangChain, right? So everything is sent at once to the LLM, which receive everything and then do the reasoning as based on the input it receives, right? So anyway, the point is, if we go back to Redis Insight, we're going to see a lot of other sessions already created. One for Alice, one for Bob, and one for Jane, right? So all those, let's call, I know that it may like a folder on Redis Insight visually. That's the intention that we're trying to use it here. But those are actually prefixes of a key, right? And then all those keys and values are now stored durably and permanently in Redis, right? As long they're not expire and as long as they're not deleted, they're actually they're stored here in Redis. So whatever other conversations take place that uses the same session ID, they're going to be used as part of the context sent to the LLM. So this is important because from the human perspective, when you create this concept of chat message history in a conversation, it creates this nice, cozy relationship between the human and the machine, as if they were having actually literally a conversation. Although this conversation is not happen behind scenes, this is always like a stateless interaction between the client and the LLM, and then every time is a new question with a potential new answer, but remembering all the history that was spoken before. So this is the power of implement a chat message history with LLMs in a LangChain application, right? And then you also have the ability to clear your histories, and even for if you accumulate it, but this history here is actually this construct that we manually created when we were interacting directly with the message history, right? So when we invoke the function clear, we're actually clear everything that was stored there, right? But also, we have the ability to reconstruct the instance of a Redis chat message history, basically providing the same session ID and the Redis URL. And once we retrieve those, we can invoke the clear message. So in this case, I'm going to execute this code, and then the chat history has been cleared. So if we update the keys here in Redis, the database is back to the empty state, right? So clearing the chat history obviously has its implications, right? Usually you are going to do this when a formal session of conversation finishes, right? When the session expires, and then you are going to clear the cache because you don't want your human user thinking that you are storing information from previous conversation, right? Ideally, right? But who knows? Maybe the use case that you are implementing might be a chatbot that remember things even though your session already expired, right? So it highly depends on what you're trying to accomplish here. So implementing code that is going to delete the history that you've created, it is an optional step, right? The point that important here is that you have the API available for you to accomplish this. And just like you can do with the other examples that we have shown so far, you also can set time to live or TTL for those messages so they can automatically expire, right? So regardless, it provides you with a complete foundation to build very smart and human-like conversation using the LangChain framework along with Redis.